Let's take a look at different concentrations of solutions and a particular problem of you've got a concentrated solution. It's way too concentrated. You've got way too much of whatever solute you want in your solution, and you want something that's less concentrated or diluted. So this is a diluted solution. It's a concentrated solution. So we've got smaller amounts of substance in a diluted solution and larger amounts in a concentrated solution. And we can actually go this way quite easily, going from concentrated to diluted. We can dilute solutions very easily by adding more of the solvent. So when we are calculating the new concentration, though, we can use a fairly simple equation. That is C1V1 equals C2V2. So C is concentration, V is volume. So C1 is our initial concentration, so our starting concentration. And our V1 is our initial volume. The C2 is our final concentration, and V2 is our final volume. Now, it actually doesn't matter whether you have both the initials on the left and both the finals on the right, or vice versa. What matters is that you correctly match the initial concentration and initial volume with each other, and the final concentration and the final volume with each other. One of the big challenges folks have with this type of calculation is mixing and matching values, because you're talking about two concentrations, two volumes. You don't want to get them mixed up. You do want to make sure and label them. This concentration can be in any units of concentration, as long as it's the same units throughout. So you can have molarity and molarity. You can have percent by mass. But if you have molarity and you have percent by mass, you can't combine those. So you have to have the same concentration throughout for these types of dilutions. So let's take a look. I have 1 liter of 6 molar HCl available. So I've got a big bucket that has 6 molar HCl in it. So this is a 1 liter container. And I want to make 1 liter of 1 molar HCl, hydrochloric acid. So I want to figure out how much of this 1 liter of 6 molar HCl I'm going to need to make that 1 liter of 1 molar HCl. So sometimes it can help to kind of sketch out what's going on so you can track what it is. Now, so we know we know a volume and we know a concentration here. We know a concentration, and it may seem at first that we know a volume, but we're not using this whole 1 liter. We're using part of it. So how much of the 6 molar HCl? So that 1 liter we can kind of ignore. We've got enough to actually make our solution, but from there we need to figure out what that volume is. So what's the volume that goes with this one? This is my V1, C1, V2, C2. You could assign them the opposite way. So I'm looking for V1. So there's 2 ways I could do this. I can rearrange my equation. So my C1 V1 equals C2 V2. So I can rearrange this equation to solve for V1, or I could plug in numbers and solve for V1. Either way, you'll get the same value. So I'm just going to plug in the numbers. I have 6 molar is my concentration. So C1. My V1 is what I'm solving for, so I don't know what that is. I have 1 molar and 1 liter for my final. I can solve for V1, divide both sides by 6 molar. and I get around 0.167 liters of 6 molar HCl. Now notice this has a lot of significant figures. I can't really claim that many. This is, kind of a rough calculation just to kind of get an idea of how this works. Now, one thing to be careful of with these types of calculations is to be careful about how you would measure this type of thing in lab. We don't have a device that measures 0.167 liters. But we could convert this into milliliters and then measure it in lab. So do keep in mind, we do have graduated cylinders that can measure in milliliters. We don't really have them in liters. So sometimes we are stuck by the realistic, so what types of devices we have. That determines what types of units we're going to have to convert to.